We have learned many things during this course. Let me summarize the key concepts of this course in 8 concise points. We know how to download any ticker from the stock market. For example, if we want a table where every row represents one day and the columns the prices for a particular stock, we go to Yahoo Finance and identify the ticker for the company. In this case, Microsoft Corporation, the ticker MSFT. We put it into the Python codes and we download it with the library Yahoo Finance to finally get this data frame. The same mental model would apply for any ticker that you want to download in the stock market. Preprocessing data for the investment strategy. We need to apply some computations to the data frame if we want to create an investment strategy with machine learning. In this case, we want to calculate the percentage change for tomorrow for a given period of time. Therefore, the two calculations is first filtering the rows and second creating a new column. We use the function log to filter the rows from 2016. Then with the function assign, we create a new column and we remove the missing data that have been produced. We execute and then we get the data frame we wanted. The third one is the machine learning system. If you want to calculate the best possible model, don't think that you will need to learn all of the mathematical equations, because in Python code we always follow the same steps. In this case, we will compute a linear regression, decision tree, and random forest to predict the change of tomorrow based on these columns. The first thing we do is separate the data between the target, the Y, and the explanatory, the X, and then for any of the three models we apply the same procedure: fit, predict, and score. The only thing that changes is how do we import any of the algorithms. Once we know, we execute and we are ready to get this data frame. The same process that I have explained is applicable to any of the machine learning models that you see on sklearn library. Fit, predict, and score. Another concept is the different types of machine learning models. It is not the same to calculate a category up or down than the number. Based on the type of variable that we want to predict, we will use one decision tree or another. If the target variable we use is categorical, change up or down, we use decision tree classifier. On the other hand, if we want to calculate a numerical variable, change numeric, we use regressor models to finally get the predictions right. This mental model is applicable to most machine learning algorithms. Decision tree, random forest, canary snakeboard, support vector machine, they all have two versions, classifier and regressor. Now, backtesting.py, the library we use to create investment strategies. The library we use to create investment strategies to see the performance on historical data, both in this dashboard and in this summary table. Based on a data frame with the prices of a stock for each day, we create an investment strategy from backtesting library, and we need to define two functions, init and self. Within init, we create the objects of the investment strategy, and within next, we need to decide when to buy or sell the stock. And once we create the strategy, we pass it to the strategy parameter in the backtest class. We also add the conditions of the backtesting, we run the report, and finally we get the performance in a table, both in a data frame and in a dashboard. Another key point of this course is optimizing investment strategy with custom parameters. Let's say that we want to set a limit when to buy or sell. For example, based on different limits of buy and sell, we get different returns. Based on the investment strategy, the conditions to buy or sell the stock are based on the forecast tomorrow if they are above a limit or below a limit. We create them as custom parameters within the strategy, we reference them in the conditions, And finally, we use the function optimize with a range of numbers from 0 to 10 and from -10 to 0 to maximize the return. We execute and we can get this table that summarizes the optimization of the strategy. Another key idea we learned is creating custom libraries that we can use in many scripts without adding too many lines of code. Instead of repeating the strategies within each notebook, we create a single file, strategies.py, where we add the investment strategies, and then we are ready to use it in any other notebook that is on the same folder. And finally, out-of-sample validation walk-forward, with the walk-forward algorithms as a realistic approach to backtesting. We see in the following diagram how to validate the investment strategies on the yellow areas, which reference data that was not seen by the machine learning model during training. Why do we need these validation algorithms? Because if we backtest the strategy with in-sample data, we may get unrealistic returns such as 500%, whereas in out-of-sample data, we get a more realistic return, 10%. In the Python code, we need to select the training data, in this case 600 days, and later create a new class for the walk-forward validation. Because we are retraining the model, it's X number of days, in this case the given by self-coef train. And remember that we have two versions, walk-forward anchored and unanchored. And that's how we create the validation algorithms in Python. Follow me to the next video, where I will tell you some advices to optimize your learning journey in algorithmic trading.